Cool. Thank you. Wow. At this hour, so many people, there's clearly something wrong. You want to be in another talk, not in this one. Okay. We're all gone. Okay. So, yeah, thank you for the interest in my talk. So, this is a less technical talk, but I'm also bringing a couple of funny things at the end, so it's not too boring. So I wanted to reflect on the Unix class that I've been teaching for a while now, and I thought this would be interesting to this audience because you're also BSD folks, so I figured this might be something you might find interesting in. So this is basically the outline that I'm going to talk about, and something a little bit about me. Some people know me already, so I'm the co-host on the BSD Now podcast. Alan asked me actually last year to join the podcast because Chris Moore didn't have enough time anymore to do it. So I'm approaching my 1-year anniversary on BSD Now, which is cool. I'm also sitting on the FreeBSD core team. I'm also involved in the FreeBSD Foundation. I serve there as the vice president on the board. Wow, how did that happen? But in my normal job, yeah, bad luck, I guess. But in my normal life, I'm a university system administrator at the University of Applied Sciences in Germany, in Darmstadt. And so this is more about my day job, less than my FreeBSD work. But I try to combine them in this talk a little bit so it's not too far off the BSD track. So I'm teaching a Unix lecture called Unix for Software Developers. And so this is basically explaining a little bit how this came to be and why I'm teaching the things that I'm teaching and why I'm doing the things. And yeah, let's start with the lecture. But first I should start with a little motivational talk that inspired me when I was starting out with Unix. So this is an old article on the OnLamp site from, what's that? Oh, what was that from? No, it's OnLamp. Oh, what was that? O'Reilly, right. O'Reilly, right. And so this is kind of the motivational thing. It's also in the introductory chapter on Drew Levine's BSD hacks. So this is also on my webpage that I'm going to show later on. So this is the theme for my lecture that I'm teaching. So Unix is for many people very mysterious, something a little intimidating, but also very fascinating. And once you get into the under the hood, you find a lot of cool gems, and really like the underlying things that are buried under the surface. And that's also what I start usually with my lecturers. So I present this to the students, and they're like, "Whoa, what's this guy talking about?" But the lecture actually started way before my time. So I was a student once, even though some people will never recognize me as a student. So I started my studies at the computer science department where I currently work in 2001. Wow, I feel old now. So back then I didn't have any Unix knowledge. So I had a DOS Windows background back then. I heard about Unix, but I'd never sat in front of a Unix system. And I had a little bit of programming knowledge, but this is basically just the start of my university career. And so my first programming lecture I will never forget because we had a very engaging and very interesting professor. And so he was kind of the catalyst for me to explore Unix a little bit more. So he basically came into the lecture room, everyone sat down, and he started the lecture with basically, there are two groups in this computer science department. The first group is using Unix, that's the group I belong to, and the second group is using Windows, that's everyone else. And after that, everyone was kind of hooked because he was kind of old school. So Professor Schütte ran back in the day Linux on his ThinkPad, and for most of the class that we were having, including me, this was a new experience because we all just knew Windows and some of the more advanced system that he was using there. So he pretty much opened his ThinkPad and did everything in the shell and the terminal. That was kind of a wow experience because way back when I liked the DOS environment and seeing the Unix environment for the first time with the tab completion and all the cool things you can do there, that was certainly something that I wanted to get more information about. And he was also a very old school Unix, or he still is an old school Unix professor, so he had the rare ability to explain complicated things very easily so that everyone could understand it. And sadly, many of the other professors didn't have that skill or didn't develop that skill. So I was really lucky to have his lecture introducing me to the more finer points of programming and operating systems later on. So it's pretty much his fault that I'm standing here today, because I not only took his programming lectures, but also operating systems and distributed systems and all that on Unix. So this is really the eye-opening experience that I had back then. So later on, way back when I finished already, and he had me or asked me whether I could help him a little bit with lab work and helping students. He was like, yeah, well, remember back when you were sitting in the class and we were still a student, and you were seeing me using Linux there back then, and he switched to Mac OS in the meantime. So that's pretty much every new student generation has the same experience. So professor opens his laptop, uses some kind of system, and they're now trying to emulate that environment, and that was kind of the idea that's going to start it there. And I talk to students sometimes that having his classes, and I see that they're having this experiences all over again, and this is kind of a nice thing to see. So back then, right around my master's level, I was also experiencing a little bit with other Unixes. So I ran Debian for a long time, and until one fateful day that I found a FreeBSD ISO image, and I was like, oh wow, you can switch terminals real quickly, and that took a long time on the Linuxes back then. So that kind of hooked me onto the BSD track. Otherwise, I wouldn't be doing this. So it's just terminal switching. It's just like, whoa, how cool would that be? How often do you do that? So that got me.
It's crazy how small things.
Yeah, just turn you totally into a different environment, and. Yeah, so from there on, I started discovering the BSDs a little bit more, ran Debian and FreeBSD in parallel, and then one day I was like, oh wow, you haven't booted this Debian system for a long time. Maybe I can do the complete switch over to FreeBSD. And that's what I did, and pretty much never looked back. So this is my main system, except the macOS.
But macOS is based on FreeBSD.
Yeah, so there's the logical progression in that, and I feel quite at home. Although people try to nag me a little bit and get a FreeBSD desktop, some kind of laptop that's running FreeBSD. But the nice thing about that is that one day Ariel Schütte approached me. By that time I was now working in the university department, because why not? And he asked me whether I would be willing, because I also took that lecture at him. So this is an elective course, and he asked me whether I would be interested in taking over the class, because he was busy in other lectures and he couldn't do it anymore. So rather than having the lecture die, I would take over the lecture, basically holding the lecture, doing the labs, and also the exam. So this is the honor of passing the baton from him to me. And yeah, this is pretty much how I got involved with this lecture. And since I took the lecture myself, I was kind of in the know of where I was going to and what I was expecting from the students, since I experienced most of the trouble that I had with that lecture myself. So I knew what kind of things needed to be fixed. So what is this lecture, Unix for Developers? So it's basically an undergraduate course that Ariel Schütte created in our computer science department. And this is all in Darmstadt, Germany, where I live. And so the goals back then is, so he noticed that a lot of people were interested in Unix, since he showed this in his lectures all the time, but they didn't actually know how to do programming on Unix, or what kind of things you could do on the terminal in shell scripting and other things. So he created this course, and did it a couple of times until he passed it over to me. And so the required knowledge is basically you took his operating systems course and his distributed systems course, and you should know a little bit about programming, and then you could basically go into these topics. So he covered a Unix overview, a little bit of history, where this all came from and what it's currently going to maybe, or where it's currently at. Editors, yes, we were learning VI the hard way, and I still well, yeah, it's not too bad. I tried also to expose the students to it, but not too much. So I know that there's immediately two groups, one that hate VI with a passion, and the other ones are like, okay, I can still work with this editor. I can do inserts and other things. Then we do a little bit of shell, what the shell can do. This is basically what most people know about, so tab completion and history and stuff. So this is all the stuff that you probably all know about. And from there, we started getting into shell scripting and things you can do there to like automate certain tasks and make sure that it runs certain tasks in a fashion that you would never have done because there's no separate program for that. Then we focus a little bit more on file systems. So back then he was teaching about how ext2 and 3, that's way back when, was working. And yeah, for me, my topics that I now changed a little bit, I will go into this in a little while, focusing a little bit more on OpenZFS because I think that's something that the students should be exposed to just see what kind of cool things that OpenZFS can provide. There's also the grepset and awk set chapter, which has most students just groan about, the crazy syntax that awk is using. But they can also see what kind of cool things you can do with awk that you wouldn't normally do or would have to do in a very complicated fashion nowadays. And what I added is Ansible, and I added that last year because I thought this would be interesting to students, and the feedback that I got after the class when the students got into their practicals before they do their final thesis is that many of the companies are looking for students to know this already coming from the university, and so that they have a little bit of knowledge about how Ansible works or how the whole configuration management thing is doing. So this lecture is basically 1.5 hours, so 90 minutes per week, and we have also a 3-hour lab every 2 weeks. So we have a relatively big lab so that students can get a couple of assignments done in this time frame, so that they pretty much can get the exposure that they need to work with the actual systems. You can do this lecture totally theoretically, but it wouldn't help you much if you're really sitting on a Unix system. So this typically is 5 to 6 labs over the semester. So this is typically 14 weeks that we have. And you cannot start the first lab on the first week because students don't know that much to do something. But this is basically how we structure this lecture. And at the end, there's a written exam, of course. So for this semester, the last exam was just 2 days ago, while I was on the way here. So a colleague of mine took over that. So he just watched people writing the exam in hands and collected it again. And which means when I come back from FOSDEM, the first thing I have to do is, create the exams. But that's okay. So changes that I made to the course, I already mentioned the addition of OpenZFS. So when I took over the slides from Alois Schütte, that when he passed over the lecture to me, the slides were already outdated, so they were covering Linux 2.6, and I was like, ooh, I have to redo the slides anyway, so I might as well push a little bit BSD into it. Because the lecture is called Unix for software developers and not Linux for software developers or BSD for software developers. So I'm trying to level it out a little bit, not just Linux, but also a little bit of BSD so that students can get an idea of what the two systems can do and what kind of differences there are. I originally also held, so the lecture was held in German originally, but with the addition our department is now doing with more international work, they asked me whether I could switch this course language over into English. And so I said, yeah, let's try this. And what I found is that it was relatively easy to do because all the technical terms didn't need to be translated at all. And I could just use some of the slides from some conferences, take snippets in there and put it in there. So it's just in English all the time. So this is the third time that I'm doing this now. And the German students like it and the exchange students, so I didn't lose any of those groups. So I'm trying to use this or motivates me to keep this in English. Yeah, and for the students, so when you start a lecture in a German university and you start in English, everyone is like, ooh, do I understand what he's saying? But this is pretty much how it goes all the time. And the second week, students kind of get familiar with the talking speed and, that you don't know all the words all the time. I mean, this is just me talking in English. And in the second week, they start warming up to the whole idea, and then they start raising their hands and asking questions. So this is also a good training for them to get into their language skills. I mean, computer science is English anyway, so they might as well practice it in the university while they're still learning, and then they can flex their muscles a little bit. There was one guy in this semester's lab, so I was constantly talking to him in English in the labs, and he was constantly repeating in German, so he understood what I was saying, but he kept repeating everything in German. So I was like, okay, you can do this, but if you want to do this, we can find a common ground here. So that was kind of interesting, but most students switch to English for this lab because they also have to work with the exchange students a little bit, so there's the common course language. And of course, I keep making changes to the course because especially in computer science, you can never stick to one topic, or with one topic you have to constantly learn yourself the new things that are happening in the systems. The systems change themselves as well, so you have to constantly keep the stuff updated, because otherwise the students would just leave if you talk about this old stuff no one is using anymore. That's why I added Ansible, and I'm already thinking about what new things I would add for the next iteration. So this is a yearly course, so I typically teach this in the winter term, which is from October till late January, and then in February there's typically the exam. Okay, so why bother? Why should I teach this class, or why should I even spend my time with students so I could just sit in the university office and do my normal sysadmin work? So I have the same motivation that I have when I took the class myself, because I think that Unix skills are still relevant today, and that students in university don't get at least in our university, I think, don't get too much Unix exposure. So I'm managing our big data cluster at our university, which is typically for master's students, and it's all running Unix systems. So we have currently we have Ubuntu on it and FreeBSD, so I'm trying to get more FreeBSD onto it, of course. But what I find is that even the master's students sometimes sit in front of the terminal and don't know what kind of commands to enter. And this is typically that they didn't know about Unix before, or that they don't use Unix in their private time. So I wanted to create this class, or the motivation is still there to have the class there so that they get a little bit of exposure to Unix and do some programming on it. And if you want to keep Unix alive, we need to train the people, and we might as well start early with that, because otherwise they are lost to some other operating system. And the idea is to even if I have a class of 40 students, maybe just 5 students will stick with Unix, and the other ones are like, yeah, this is nice enough, but I'm going back to my other Windows systems, or Macs even. But even the 5 that are left with the Unix impression or the Unix spirit, these are 5 more Unix people that we now have, and they might become developers for some open source project one day, so this is already a benefit. They also need to, or should know, how to use Unix tools, because as you know, it's very flexible what you can do with Unix tools. You can combine them in different ways, just using pipes and all these things. And knowing about this is very good for students for their toolbox that they now later on bring into companies, because then they can say, oh, I can work on this CSV file with awk, or I can write a shell script that does certain things on a server, or I can use Ansible to do certain automations. And that's certainly something that students should know, and then they can apply this also to many different other fields. But then people ask, yeah, why are you using BSD as a teaching tool? So why are you using this? Why can't you just use the Linuxes of this world? Well, the reasons are relatively simple. If you only have a hammer, then every problem looks like a nail. And so if people only use Linux, which is good, which is totally fine if it solves a problem, but sometimes people try to apply the wrong solution to the right problem, and if they don't know about that there are other systems out there, they just try to apply the same solution, which might not work. But if they know, there's this other operating system out there that has other cool features that might apply better to this current situation or this current problem, then they're far better off, because they have a better way to decide which problem to fix in this way. And of course, there are some features in the BSDs that the Linuxes don't have, or not yet have. So like OpenZFS or boot environments, Alan was talking about this earlier, and some of the FreeBSD-based system utilities I just don't want to miss. So I typically show in the class relatively many demos. Some fail relatively spectacular, but I switch between systems very often. So I show them top, for example, and I can tell them, hey, look, in FreeBSD I can say top 10. and on Linux I get an error message when I enter that. So it's these small things that students experience in my class and see, that's what's working on this system, and this is working on this other system, so they can decide later on which is better for their own purposes. And of course, the sources are available. That's also true for the Linuxes, of course. And they can also, they allow it to play with those, tinker it, change it, and work with it in different ways. Yeah, so some people ask me, hey, how can you teach if you're not a professor? So I'm not a professor, I'm employed at the university. And some people think that only professors can teach at the university, which is not true, at least not in the way that I do it. So in Germany, you can typically go to a university and say, hey, I'm an expert in this kind of way because I have work experience, I've worked on this particular operating system or this particular topic in computer science, if you want to go that far. And are you interested in that? I can talk, I can give a lecture about this. And many of the universities look for people like that because they cannot hope to cover all of these different subjects that are out there, and students are also interested in getting practitioners in their field to talk about in class about their experiences and how it works in the real world later on. So that's my encouragement for you to, if you're interested in teaching and all these things, that you should also maybe approach this. The pay is probably not the best motivation for that, but it's certainly interesting to have this interaction of teaching and learning and seeing students get better over the semester to get more exposure to the system or to other areas that you're interested in. So for me, it's a good combination of my sysadmin work that I'm doing on the big data cluster and also the lecture that I'm giving, because I can carry over some of those tasks that I'm doing on the big data cluster into the lecture, and also this way give the students a little bit more ideas of what their later work might look like. So they might have to solve the same problems that I'm telling them about. So they might as well figure out solutions for that right away and not later on when they're in their job. So I try to make a lot of practical examples, and if I'm trying to do something all over again on the cluster or something, that's probably something I should automate one day. So that's why I'm doing a little bit more with Ansible, and then students see, so typically my lectures go like this. I present a problem, then I'm showing them possible solutions on the system, and then they can see, he's solving it in this way, and there is a little bit of discussion happening typically, because there are often multiple ways to skin a cat. Yeah, so typical challenges when I start the semester, because students don't know me, I don't know what the students are like. So typically, since this is an elective course, I typically get the students that are already a little bit interested in Unix. I don't get the people who hate Unix with a passion, because they don't have to take the course. It's not a mandatory course. So I already have a little filter already that students who are working with Unix a little bit or just want to see what the system can do, that I get those students and not the ones that I probably never see in this class. But then, so I start telling them a little bit, when classes are and how many the exam a little bit, or how many labs there are going to be. And then someone raises his hand in the back and says, which Linux distribution are we going to use in this course? And I go, all and none. So if you have a Unix distribution that you like and you can use that to solve all of the labs, then by all means use it. I'm not indoctrinating you in any way. I just want to show you another system, and if you hate this other system at the end of the class, that's fine. Use your own system. But for the students that are new to Unix anyway, I should give them at least some system that I think is best for them to learn with. And that's typically, so that keeps the people who say, I want to run my Ubuntu, or I want to run my Arch Linux, or whatever. And they can use that by all means, yeah. They can pretty much solve all the labs that I'm presenting them. And for the new students who are totally overwhelmed with the stuff that I'm presenting to them, I want to keep them in the class as well. So I should not drive them away by scaring them with a new operating system. So I'm trying to get these two groups still in the same class. Yeah, that's what I said here with don't bore the first group. So some of the students already know more than I do. So they are like, yeah, okay, I just come to the first lecture and the last one before the exam, and then I'll see how I go. That's fine because they don't get on my nerves this way. But some of the students, well, yeah. And they pretty much finish off pretty much all of the labs in one go, and I'm, okay, you're the expert. You can teach me a thing or two, but you just need the labs for the actual exam later on. So, but most of the students are relatively new, and we have many students who have a little bit of knowledge of Unix but want to know more, and these are exactly the students I want to have in my class, so I'm not trying to scare them away too much. And ideally, even for the more advanced students, they should also know something new. So they probably never heard about OpenZFS or what Ansible is and what it can do. So this is the new parts that also makes them stick to the class. And the first lab actually is the most challenging one for me, because in this one I try to bring everyone together. So the one group that is the experts who have installed probably 50 Unix systems in their lifetime already, and some of them say, oh, I'm a system administrator in this company I'm working for in the meantime. And I'm like, okay, sure, then go ahead, install this system that I'm presenting. But the people who are new, they've never installed the Unix system before, they want to have a little bit of hand-holding so I can help them a little bit if they enter a wrong command or created a data set that's not the proper name or things like that. They need a little bit of help. So that's why I'm having Lab 1 being the one that tries to sync everyone to the same system, because we're basically installing a FreeBSD system from scratch. Because although people say that the installer is bad, pretty much every student could install the installer using the installation menu and go through the prompts, and that's pretty much not what computer science is about. They want to know what's happening in the system. Why are we partitioning disks? Why are we copying files over and extracting them in certain directories? So this is the idea that I'm trying to give them there. Why are we using this system in the way that we're using it?
May I ask?
Yeah.
Do you explain this stuff like partitioning and so on the first lesson? Because there are a lot of topics related to just installation.
Yeah, so the question was whether I explain these concepts of partitioning and other things that I'm using before the actual lab starts. So the first lab is more descriptive, so it's kind of a FreeBSD handbook chapter light to install the system. But I give them also assignments, so they should not just blindly type any commands in there. They also need to figure out what are the device names, what are the ifconfig interfaces they need to configure. So these are the things they need to figure out in the lab themselves, but the rest is pretty much, a partition is a logical division of a hard drive in this case, and some of the things that I'm explaining. I'm also explaining them later in the labs or the lecture itself. It's just that the timing isn't right. If I would explain the system all in the labs later on, the lecture would be lagging behind and vice versa. So it's a little bit of trade-off.
It's a master course, not bachelor's.
No, it's a bachelor's. It's undergraduate.
It's bachelor.
Yeah. So yeah, that's the lab 1. So this is the most difficult for me. But lab 2 is then fine, because then they have a system set up, and yes, students try out things and rack their system in interesting ways. That's why we create a boot environment in the very first lab, and I'm not giving them the lab for the Mark 1 until I see that they have a boot environment ready to save their neck. And this helped me a lot, because if students find out in the 4th lab that their system isn't booting anymore, and it's like, oh, well, you have to reinstall the whole system again. Not anymore. You just restore the boot environment, and we're back to normal. So this way I can make sure that I sleep well, so that students don't send me email messages in the middle of the night and say, oh, I've crashed my system, can you help me? Yes?
What's a boot environment?
So boot environments are a ZFS feature. That's why we're installing a FreeBSD on ZFS. Oh, the question was, what's a boot environment? A boot environment is basically a way to use OpenZFS to have multiple versions of your operating system or your file system, in this case ZFS. And if you want to know more, Alan gave a talk 2 hours before this one about it, and there's also a bunch of things. I also covered boot environments in the lecture a little bit, but this is a typical question a student would ask me also in Lab 1. What's this BEADM system I'm using? I've never used this before. Okay, that's fine, but I'm explaining it. So we have a chapter in the lecture later on about file systems, and that's where I explain what ZFS is and what is a pool and what is a data set, because most students have never heard about this. Of course, I cannot cover the whole ecosystem of OpenZFS. That would be a lecture of its own. But the basics are there. I mean, you just need to know what a pool is and what a data set is, and then you cover snapshots a little bit, and that typically gets them knowing what this is all about. Okay, so this is the challenge that I have. So the labs themselves, I covered them a little bit already. So lab 1 is bring everyone on the same page. We install a FreeBSD system in VirtualBox. Yes, a couple of people tried it in KVM. That's also working. And so it's just having the same environment for everyone. 2 years ago, I let students install it on their own physical machines. And there was one student was like, well, he didn't apparently do the partitioning right or the boot environment management. So what happened was he was trying to boot his Windows system again, only to find out that it wasn't there anymore. And the student for the rest of the lab was just sitting, staring blindly at his laptop, and going through his head what kind of systems he lost and what kind of software licenses he had to get again. So that was kind of a letdown for me. So that's why I'm using it in a controlled environment. And because in VirtualBox all the devices have always the same name, no matter what kind of hardware the students bring. So we're not doing this on lab machines, so every student can bring their own machine. And so I have Asus the ThinkPads of this world, so all kinds of different hardware. And the exchange students have even more crazy hardware. So we have students from South Korea, and even the keyboard layout, I want to try to help them a little bit and type something in. I was like, well, why don't you type a little bit? But it's interesting for me. I learned a lot of stuff helping these students, and some of these systems, they're only 32-bit, so they cannot emulate a 64-bit FreeBSD system. So I was hoping they all die out by now, these old 32-bit systems, but they're still out there. Lab 2 is basically setting up an X environment, because we're doing some GUI stuff later on. It's relatively simple, but I want to have them not just work in the shell. So we install a little bit of an X environment. I'm using Fluxbox currently. I'm probably next year switching over to Lumina, so I'm trying how this works for the students. So this is a constant experiment, and students are also a little bit of my guinea pigs, so I'm trying new things on them. Then lab 3 is about basic shell commands. So, chain of pipes. I'm doing a little chain of pipes contest. So the group that creates the longest chain, so with the most pipes in between, that does something useful on Unix, they get a little prize. And so this is kind of interesting how many pipes you can put into a system. Like they like get something from a file and paste it to something else, and then filter out something. And it's certainly interesting what people come up with. And then what I noticed is that students should know a little bit about GraphViz. Why? Because students later on will write their thesis about some kind of topic, and the chances are relatively high that they should visualize something there. And I found GraphViz really easy, because you just provide a couple of instructions, and the computer is creating these nice graphs that you can see. So I find this very helpful, and students from 2 semesters after they finished my course, they said, thank you that you showed me this GraphViz thing, then now can I create my thesis quicker without having to learn this GraphViz utility or some other GUI graph environment. So lab 4 is, so by the time we'll reach lab 4, we already covered a lot of programming in the lecture. So we're doing shell scripting there, and a lot of basic things, cdialog things, and creating a boot environment menu, so they can have a little GUI environment to select the boot environment they want to switch to, and things like that. Lab 5, so originally we had 6 labs, but time constraints in the lecture or in the semester kind of had me cut the last lab, because it's too close to the actual exam, so students should focus more on the exam by then. But lab 5 is basically integrating grepset and AWK into shell script, so that they know which environment they're currently on, because $1 is different in the shell environment than it is in awk, and they should know the difference between the two and how to pass like variables from shell to awk and vice versa. So that's what this lab is typically all about. And each of those labs has a little bit of OpenZFS in it, so I'm not having a dedicated lab for ZFS itself. Well, lab 1 could be, but there's much more steps in lab 1 than just ZFS. So there's always a little side assignment in each lab that says, let's create a couple of data sets, and set different compression level, and then extract the ports tree on it and see which is the best one for this case. so that they know also a little bit about the differences between the algorithms that OpenZFS is using and things like that. Okay, the exam. Oh, this is kind of a nice section in the presentation. So the exam questions typically focus on the stuff that I covered in the lecture, of course, and some shell script writing. So I typically ask the students what kind of helpers they want to use. So I have 3 stages. So an easy exam does allow no helpers, so nothing. They just bring their brains, hopefully, and their writing skills. A medium-sized difficulty exam will have them bring a piece of paper that they wrote themselves. So if people are like super nervous and get blackouts, they still have their piece of paper where they wrote certain things down. And I also give them the choice to have a very difficult exam where they can bring everything, computers, books, but no group ever selected this option. I don't know why. Most of them chose just easy exams. And that's what I typically do. So in an easy exam, yeah.
So they have just paper and pencil, no computer?
Yeah, exactly. They cannot check their source code, but that's, if I have an easy exam, I say you must at most write 10 lines of shell. And I think that's parsable in your in the brain that you have at that point. And or sometimes I give them source code that's wrong, that has errors in it. And at one point I had a shell script that has like 3 syntax errors in it. And the first one was in line 1, so I switched around the bin sh, so it's hash bang bin sh, and I switched around the bang and the hash. And there was one student in the lab or in the exam sitting 5 minutes. The last one, everyone left already, had handed in their exams. That person was like, I want to find this one error in this exam. And he was like totally crazy. And I said, okay, hand it in. If you hand it in, I will tell you where the error is. Okay, so he handed it in. It's like in the first line, the bin sh was switched around. And he's like, oh no. Because this is the line that everyone is not looking at, and they just think, it's just working, and yeah. This is fun. Yeah, but no student ever failed this class, although some exchange students last semester tried really hard. So what they did, they wrote the whole exam with pencil. I don't know if that's a thing, but that's what I did. And then before handing it in, they erased everything again. But so badly that I could still read the stuff in there. So I graded it as normal. They barely passed, and yeah, I wish them well. They probably will never use Unix again. But here I have a typical question from my exam, so maybe you know about this one. So Doug McIlroy formulated 3 ideas that form the basic philosophy of Unix. So this is my introductory lecture typically, where I talk a little bit about Unix history. So you probably heard about this before. Write programs that do and do, yeah, yes. Second one, write programs to, yes, and write programs to handle text streams, because that is a universal interface. Excellent. You just passed. So here are the solutions. So here I photographed a couple of the solutions that students handed in. Exam gold. So this is what the first, so this is after grading it. So this is typically what you get. You can see already that they didn't learn this question. So it gets better. Stuff is always the right solution. If you don't know the answer, it's stuff. Make life easier. Yeah, of course, why not? That's what programs are for. Next one. So this is a 3-point question. How much can you lose in this one? Right? Yeah. I like the means part in this one because, yeah. So this, you sit down with a stack of exams to correct, and correct, wrong, correct, and then you read certain things like this, and this kind of brings a smile to your face. And I saved the best for last. Write programs that do enough and do not, what? Okay. Next one is write programs to automate processes, and write programs to handle this test because it's a pain in the... Okay. That's all kind of feedback for me how the difficulty of the test was. So this is the stuff that I have to deal with. Yeah, so things that I noticed from the students indirectly or from the feedback that they gave me about this class, so that many of the students nowadays come with computers that have only a GUI environment. Some people bring their tablets, some people bring their mini laptops that have only a little GUI on it, and then telling them, well, you have to go to this black and white input environment. That's kind of a horror for them, because that is like the old ages of the computing environment. So, but more and more students are bringing these, and they have never used anything else before. So they're all using GUIs, and it's kind of difficult to bring them into the Unix environment if they only know GUI environments and mouse clicks. And of course, this is typically for the students who have already used the Linux system a little bit. They think that bin bash is the prompt that you should use for shell scripting, and they write perfect scripts, and then I say, well, why are you using bin bash? You can run the same script with bin sh, because you're not using any specialties that the bash provides in this programming. And they are, oh, interesting, I didn't know that it worked in bin sh, so that's probably why, yeah. And then I tell them about portability, because trying to port this bin bash script to a FreeBSD system or some other Unix system won't work, because that's a different path. Because bash, as you know, is not in the FreeBSD base system. And then they say, yeah, okay, I change it to bin sh, and then they're reluctantly changing that script and hand it in. But there's also things, so I always view teaching as not as a one-way street. So as much as I teach the students, I get as much information back, even though they don't actively teach me. So the feedback that they give me indirectly is, when I'm holding a lecture like this, you don't have to be perfect. You don't have to pronounce every word correctly. They still understand what you mean. They also, if you have a bad day and give a very bad lecture, and at the end, a student comes to you and said, oh, wow, I learned as much in this lecture as ever. And it's like, ooh, wow, great. So don't worry, be crappy. You can still teach enough students that they will not hate you forever. And you don't have to do this old stick, okay, so they were learning about Unix system. Yeah, loosen up a little bit. You can do this, maybe not on the first time you're doing this, but students typically react to this, more lively interaction, and they like a little bit more some jokes in the lecture, for example. So, and Unix pretty much provides the best environment to do this. So sometimes, so I've been SL installed, and if I mistype SL, then the train drives through my screen, everyone laughs, and yeah, that's how it. That's how you keep the students interested in. I mean, 90 minutes lecture is already hard for some students. But yeah, this is the world we're living in. So this is the stuff that I try to do in the future. So I think when we're in a nice desktop environment, we also should let shell script send notifications to the desktop, so they can see, there's something happening, and that you get some kind of feedback from the shell script. The lecture is also going to change a little bit, so I'm trying to do a little bit less of slides. So typically my slides look very much a wall of text, but I'm not reading the slides, so I'm just giving the slides out for students so that they can read it afterwards in like a prose text. And I'm doing a lot of demos in the lecture, which has me prepare the lecture in a certain way. So if I'm teaching a section on AWK, I need to brush up my actual practical experience with AWK, because I might not have used it in like half a year, and then I need to see whether all the scripts still work. But doing this on a live system is much more interesting to students rather than reading it from the slides, because if you put stuff on slides, yeah, everything works on slides all the time. But if you're doing it on a live system, you can see all the different things that break, or that someone has changed something in the operating system which you didn't know about, then, oh, the commands I was using don't work anymore. I should change that and fix my slides. I'm also thinking about introducing dtrace to students. I had George Neville-Neal teach at my university for 2 times already, and the way that he teaches dtrace is very unique in the whole TeachBSD approach. But my lecture is only limited to like 14 weeks, and it's kind of difficult to cram dtrace into there. I want to give them not just a brush overview from dtrace, but also focus on actual problems they can solve with dtrace. And I think of creating its own lecture for dtrace for the undergraduates. So I'm still thinking about how to integrate this properly. I also find performance measuring super interesting, and I also want to expose the students to that, because that's probably what they're also going to do later on in their jobs. They pretty much have all the programs written by then, and it's just programs behaving badly and having performance problems, and that's what they have to deal with in the future. And people who don't know this, so Kahoot is a interactive application where you can ask questions and the students can answer them on their mobile phone, and you can get a kind of a result here, what kind of answers the students were giving, and kind of a statistic. And that's how you can also say to students, okay, these are the slides that I was presenting today. Let's go home, and if you didn't understand anything, do this Kahoot thing to like a self-control, and this way you can see what you learned in this lecture or what kind of stuff you need to repeat again. Yeah, that's pretty much the end of it. Yeah, perfect time for questions.
How many students in average do that Kahoot questionnaire?
Yeah, I need to create that first, so that was the thing that I want to do in the future. I haven't done that yet, so that's my, oh, sorry, yeah, I need to repeat the question. So he was asking how many students are using that Kahoot. So I haven't created the questions yet. I need to basically go through my slides all over again and think about questions that they should answer, which shouldn't also be exam questions, because otherwise it's too easy. And if you ever create a curriculum, then you can see that you can only ask so many questions, because the material is there, and you can only ask questions about the material that you have. And if you don't have enough material, then you pretty quickly run out of questions. But this is certainly an interactive way, because you have always students sitting in the back, and you know, they have their laptops open. I can see that they're on Facebook and not on my lecture slides. So, yeah, but that's the way it is. That gives a little bit more interactivity to a relatively boring lecture. Yeah.
From the students, is there any particular running theme or feature that the students like?
Yeah, the question was whether there's a theme that the students like or what they want to see in future lectures. Yeah, so they're interested in the Ansible stuff, definitely. That's why I'm now teaching this also at certain BSD conferences. Because the topic is still relatively new, the whole configuration management stuff. And OpenZFS is definitely interesting to them, because most of them have never heard about this. And they're also seeing what features it has. So I cover snapshots and boot environments, as I said. So they're like, ooh, wow, that's in an operating system's file system? Wow, I need to check this out. And that's typically what I get as feedback.
One
Yeah.
second before
Yeah, sure.
letting you finish. For those living, we need to leave the place clean. So if you have trash around you, bottles, whatever, you have a trash can leaving this room. On the outside is a big one, so you can put everything on it. Thank you very much.
All right. More questions? Oh, here we go.
You answered my default question, but there was a question on the internet if you introduce SIG-info to your students.
Oh, yes. Yes, I do. Yeah. So that's typically what I do when I tell about differences. Whether I introduce SIG-info to the students. Yes, that's what I'm doing. I also write articles in the FreeBSD journal about SIG-info, even though they are small. So SIG-info is one thing where you can say, oh, look, this is different from the Linuxes of this world. And if I type Control-T, then the system gives me something back. And I also will cover traps in the shell scripting section, so that they can write their own Control-T handler. And they can say, oh, this program is now giving me that message. And this other key combinations creates other messages here. So this is typically the difference between that I'm trying to focus on in the lecture. Next. Oh, wow. A lot of questions.
Is it necessary to study and associate C programming with students?
So yeah, the question was whether there is C programming in the lecture. Originally there was, but again, if you teach a whole programming language, well, they cover programming in the first 2 semesters, which is C++. And so Professor Schutte did it in a way that he only covered the differences between C and C++. But again, if you cover C, then you can not do it in just one lecture. You can do so many things in C. And if you're doing programming in Unix in the kernel environment, that pretty much warrants its own lecture, because you can do a lot of stuff in there than just the things that I cover. But it's certainly worthwhile teaching that to them. This could be the 3rd lecture that I'm teaching. Oh, wow. If I'm not appearing in any future BSD conferences that you know, I'm totally stuck now in teaching at university courses that I think are relevant to them. Yeah, this is the trade-off that I'm doing. Yeah.
When you're looking to add new content to your courses, what do you look for? What inspires you to replace something? Do you have a certain teaching goal in mind, for example?
Yeah, so the question was, when I add new content to the lecture, what are the things that I'm looking for, or what inspires me to add them? So typically I add stuff that interests me, because I typically create lectures that I wanted to visit myself, but they weren't offered back in the day. So I'm also switching interests a couple of times. So I'm currently totally into monitoring and, a little bit into DevOps. I'm also going, but I cannot put everything in this one lecture. It still has its own theme, it has its own curriculum, but if I find if I finish a topic earlier than I was anticipating, then I add a little bit of stuff at the end before the exam starts, so that this is not in the exam itself, but students who are interested in this, they can see, oh, this is also happening on Unix, or you can do these things on Unix. Follow-up question?
Yeah, so you're basically following the trend or the market.
Yeah, so I also see I'm also following the trend or the market a little bit. Yeah, a little bit, because it interests me, and I think that's also interesting when the students going out into the industry to work there. And if we don't teach them the stuff in university, then they have to be trained on the job, and that's a little bit late. Or they don't get a job at all, which is worse. Yeah. And we should also teach them to learn stuff for themselves. They cannot just sit there and let someone else talk in front of the class, and don't start learning yourself. That's the actual goal of the whole university education. Follow your interests, do what you're interested in, and then get interested in certain things. Yeah.
Thanks, very interesting talk. I didn't say it, but have you considered to introduce your students to version control?
The question was whether I was introducing my students to version control. So I keep that for the first and second semester, because they are doing a little bit of version control there with Subversion and Git. Yeah, that's already the flame war starting. And it's typically not part of the lecture, but I could do a basic Git introduction there that isn't too difficult. But they don't have to have version control for the small assignments that I'm giving them. I could do one that covers the whole lecture or the whole exam period, or I could do a project that covers lab 1 to 6 that they have to follow along. That would be something I could try, but there's no necessity in this case to have a big version control where you have mergers and different conflicting versions around. Typically the students program on their own device, show it to me, and I'm marking it up as complete.
You said that some of your students continuing using FreeBSD. What are the main reasons for them, for example, not using FreeBSD longer than in your course and continuing using Linux?
Yeah, the question was whether some of the students that continue using FreeBSD, and whether that's or what the reasons for that are, and why are they not going back to Linux. So the outcome is relatively small, because at first I don't see what they're doing after my class, so I always send them a message after the exam, hey, congratulations, you passed, and I want to keep in touch with you, or you can still send me questions even though the class is officially over. And few students sent me a message a couple of years later, oh, I'm now working in a job, and what you told me in AUK I didn't see back then, but now I'm totally in this environment, I need this. That's a little bit late to figure this out. But the outcome, it's not an indoctrination class to FreeBSD. It's not my intent to show them, oh, this is the one true operating system. I want to give them a broader view that there's not just one system out there, whether it's FreeBSD or Linux. I want to broaden their horizon so that they can apply a certain problem with one system or the other. So the outcome is typically, out of 40 students, maybe 2 or 5 maybe will use FreeBSD after that. It's kind of a bad outcome, but the 5 students who are using it, they will stick with that. And some of the students just can't be taught to use this particular system, because I don't want to tell them, oh, you have to use this one system from now on till the rest of your life. That would be bad. I wish there would be more people coming to me afterwards, oh, I want to join the FreeBSD or other open source operating system projects, but I think I give them enough tools and insights so that they can start this later, because they're also studying 5 other classes in parallel, and they need to work those as well as my class. And maybe after, you don't know what they're doing in their free time, so maybe they have other interests in doing offline open source projects, things like that. Actually, if you're looking for the slides, they're available on my webpage here. You can find them in the, I uploaded the slides already. You can just click this one and you can get to my webpage. And that's where you find all the lectures, all the exams, not the exams, the actual, that would be nice. Yeah, students finding this link and it's like, oops. But here are the actual slide decks. There's a little ZFS introduction. There's Ansible for the students interested. There's a trial exam. Hopefully I uploaded not the real exam there. But yeah, if you're interested, look at the slides. There's also the lab assignments if you want to do them. Oh, now I'm getting from random people lab assignments complete and they want to have them marked up. But yeah, this is the giveaway for people to just look at this. I mean, most of the content for you will be boring and it's just repetition of the basics. But maybe there's something new in it for you. So, or give this to other people. There's no copyright or anything. I hate people just hiding their lecture slides behind some learning portal and put a password on it. This is open source still. This is stuff you should give to people because education is there for educating people, not hide it from them. Anyone else? Yeah.
I have maybe longer questions, so I'm not sure.
Or you can also do it afterwards.
We are completely out of the...
Out of time, out of any... Oh, there's a minus between the available time left. Ooh.
You said very interesting thing that students are asking questions.
Yeah, they should.
I'm from Czech Technical University in Prague, and I'm currently working here. And here, problem maybe it's based on national drills or something, that students barely ask questions. This semester I have one course, and I was trying to make students more active to ask why I was asking them questions.
Yeah, that's difficult.
And, trying to somehow...
Class dismissed, by the way.
Yeah.